Working smarter is how we as environment artists build things at scale quicker. So today, we are looking into how to do so by using Unreal Engine's procedural content generation. For this one, we invite Eugene Kim to be on Extend, who is currently working as a senior environment artist at Atomic Arcade and has worked on games such as Call of Duty Advanced Warfare, Call of Duty Infinite Warfare, Apex Legends, and Destiny 2 Forsaken. But for this one, Eugene will actually be looking into his own explorations with the procedural content creation tools. So welcome Eugene to Beyond Extend.
For today's workshop, I wanted to discuss procedural content generation. For the sake of the workshop, I'm going to kind of talk about it as if this is the first time you've heard about it. I don't know how much exposure anyone's might have had on playing around with PCG tools within Unreal. But the way I'll structure this is basically kind of showing you how PCG is currently being used in a very basic form. I'm sure you've all seen the Electric Dreams demo from Unreal a couple of years ago. 5.2, Unreal 5.2 is when they released procedural content generator or generation, and it's still currently in beta, but it's definitely gotten a lot better after three more versions now that we're at 5.5. But yeah, I've set up a little demo scene sample map for you guys to kind of go over things. Just to kind of start from the basics, what is procedural content generation / PCG? It's basically a tool within Unreal where basically within the confines of a volume or a spline, points will be generated. And with those points, you can essentially swap out static meshes. There are a lot of cases where you can use it in very, very specific ways. But for the sake of this workshop, and because we're all environment artists here, I'll go over a tool that I built that specifically caters to environment art in this situation. Without any further ado, let me get straight into this quick demo for you. So what I have here is a very standard spline, enclosed circle. It's a blueprint, and the way it works is you're going to hear me kind of talk about, I use cooking as a metaphor a lot because one, it's easier for me to understand when people explain it to me, and two, who doesn't love food, right? So let me go over here. I'll select this guy for you real fast, hit Control B. And as you see here on my content browser, I'm gonna double click to open up this graph. Just to show you what I did and break it down, I'll kind of, I think this is my way of basically kind of showing you the most basic usage of PCG. And then once you kind of see the breakdown of it, how the sausage is made, I'll move over to my procedural mesh blueprint. So for this guy here, all I did was I added two components, which is a spline and a PCG. And think of blueprints as the pot, right? And then PCG graphs are the ingredients. In fact, my experience working with PCG, a lot of the times people refer PCG graphs to PCG recipes because the graphs are basically the data information that houses everything that you want, and the blueprint is basically the vehicle in which the PCG graph is used within the maps. So here I created a spline. If I go over to viewport, all you see is an enclosed circle, and basically what I'm telling the PCG graph to do is everything within this enclosed circle, I wanted to generate points. And then over here for the PCG slot, all I did was I created this PCG graph and then I slotted it into this graph over here. And when I open this guy up, you'll see this complex node system, but don't worry, super simple. I'll break it down very easy for you. So let me turn this off, deactivate all the static meshes. Basically, everything when you use PCG, because everything's being used in real time, you have to be careful not to overly complicate things. And I say that because if it gets to a point where PCG is trying to understand very complex things all at once, it'll crash your Unreal, and you kind of want to avoid that. So going from left to right, I'll just break down what I did here with this very basic PCG spline. So get spline data here. All it's doing is saying, hey, this spline in the blueprint, call it into PCG. And then from here, spline sampler, this is where PCG starts. This is where it begins to generate points. So if I hit the debug tool, you'll see a bunch of these white squares. And these squares signify different points within. So you see this grid in Unreal. Imagine this grid is down to its smallest decimal to and what PCG is basically saying is everything within this graph, I want it to generate points. And that's what I'm doing here. Over here, attribute noise, what it does is it says all those points within this spline from 0 to 1, mark it up. So black being 0, pure white over here being 1, and everything else is between 0 to 1. That's what it's doing here. And then here, density filter, it's saying anything that's darker than 0.5, remove it completely. So if I toggle between these two debugs, you see how it removes anything that's super dark. And what that's doing there is it's, in the case of PCG being used here, PCG is best used as, natural terrain on landscapes. You want to generate trees, grass, bushes, etc. So because of that, it randomizes a lot of these points for you. So if I turn that off here, and then I turn on transform points, all this is doing here, this node is saying every single point that you see from 0 to 360 and everything in between, take all those points and just slightly turn them within that range. And that's what I'm doing here. And so if I turn that off, and then I bring the static mesh back on. Oh, that's the wrong one. E. Here, I just put some fern in. And what it's saying is all these points that you see here, just swap them out for these little fern bushes. And let me zoom out here. So I've set it up in a way where you have one that's specifically for fern, and then I have one for a bush, and then one for trees. You don't see it here because the circle is really small, but if I move it around in the world, you'll see that there's some spots where trees will generate. But the cool thing about this is, you can move it anywhere in the world and it will never be the same. The beauty about PCG is, you can just grab a point, pull it out, bam, look at that, you got grass. And there's a tree. And from here, you can, I won't go too into detail because it's going to be like watching paint dry, but you can essentially control how dense you want the trees to generate, for example, under this node tree over here. This is where the trees are, I believe. So here I set it to 500, meaning that every 500 units, we want trees to generate or take those points and then generate a tree mesh there. So that's kind of what that is. That's a quick breakdown of what these guys do over here. Just to kind of show you some of the limitations of the PCG stuff. You never want to scale it because it's just going to enlarge the meshes as well. So you always want to just grab the points and then move it out. And in this tree here, you'll see that I have some nodes that I'm not currently connecting. And the reason why I do that is because right now for this spline, if I move it in the world, you see how it's floating up. It's not touching the landscape. This disconnected node here, basically what I'm saying here is, hey, take the landscape information that I have here and then project whatever points I'm generating within the circle onto the land. So regardless of how high this spline is, it'll always reach, the points will always come down on a Z point to touch the landscape. So let me just show you over here. I'm gonna turn these guys off for now so I can show you a quick basic sample. Disconnect this guy. So as you see here, it's now routing the transform points, these guys, to the landscape data through the projection. So if I put this here, source, we bring the ferns back, we'll lift this up, always snaps to the landscape now. And it's not limited to just the landscape. The beauty of using the projection is that you can connect, if you just want like a hard surface of like, you want to do like an overgrown abandoned city or something, and you have like sidewalks and roads, a mesh for that. You can project the mesh onto, you can tell the points to project directly onto that. It doesn't have to just be a landscape. I'm just using landscape in this demo. So there's that. And then up here, you'll see that I have a exclusionary spline here. Very simple thing. Let me turn these guys back on real fast. Cool. So what I'm doing here is using the difference node, I'm calling a different spline, which in this case is this squiggly line that you see here. And when I set up this blueprint here, super simple. All I did was just put in a spline line, and I just told it to, oh yeah, just scale the visualization so you can see, it's this thick spline. And all it's doing is nothing complex. All I'm doing is I'm using the difference node here. As you see, it's connecting all the way down here, and then it touches this difference node. And basically what I'm saying is that take the source of these points being generated within the circle, and whatever this spline touches, I want it to remove those points completely. So just to show you an example, I'll select this guy here. Move it over. Yeah, so as you see here, it removes every point it touches. And it's not just limited to the whole thing. You can literally move some points around and make whatever path you want. And yeah, this is a really quick and easy way of showing, if you have a PCG generated landscape with all these trees and bushes, and you don't want to spend meticulous amount of time foliage painting each individual bush and fawn or flora and tree. This is a good way to just exclude a path. And then even with this spline, you can make it more complex. You can input a mesh in here and tell it that whatever points are being generated on that mesh, like for example, if it's like a dirt road, you can do have the same effect here. But for the sake of the demo, I have it so it's, just a regular spline. And from here, the bound modifier, this is where you can control the thickness. And you don't necessarily always need this. This is just specifically for the sake of this demo, where if I put it up to like 200, or 500, you can thicken how much of the points it removes. And if I turn on the debug mode, yeah, you can see that thickness of a bunch of white cubes that are essentially nullifying all these points that it touches. But yeah, that's pretty much a very basic version of PCG and how it's commonly used. Oh, and I completely forgot. In order to activate PCG by default, because it's still technically in beta, you have to go to plugins, type in PCG, and then all you need are these two plugins activated: the General Procedural Content Framework and the GeoScript Introp. Everything else you don't necessarily need, just these two. But then yeah, you'll never see the PCG graph thumbnail appear until these two guys are turned on. So that's it for the basic version of it. So let's go to the procedural tool that I made, which is taking the logic of generating random points on the landscape, but confining it to generate directly onto a mesh itself. And on top of that, I've set it up where the blueprint for the mesh is dynamically swappable. And what I mean by that is, let me bring this down here for now. It's like this guy. So this blueprint allows you to drag and drop different type of meshes. So let me go here. For this example, I've set this template up to automatically use this rock, but you can create, it's only a template. So basically you can make a child version of a very specific thing that you want. And I'll show you in a minute how I do that. But for this demo, as you see here, there's a bunch of these little points that are being generated. No matter which direction I go, it'll always move the PCG points to exclusively the Z points of the axis. So it'll always have these guys generating on top, which, this was specifically built in mind to, kind of solve the issue of like adding moss to rocks, right? Rather than individually painting things in, it's easier to just have a tool that automatically generates all these points for you. But not only that, I also wanted to create it in a way where it's very artist friendly and you don't have to ever open up the graph. But because this is a workshop, I'm going to open up the graph and show you how the parts are being made here. And yeah, just to kind of show you a quick demo between foliage painting on static meshes versus this tool, I'll show you some of the limitations here right now. So on the right, we have a static mesh of the same rock. Let me turn this guy on, and then I place a bunch of ferns on this guy, right? So like, cool, yeah, like Eugene, why don't I just do this? Doesn't this give us a bunch of time? I think you'll see here, one of the issues here is, yeah, sure, you can move it around, but when you rotate it, the foliage also follows that direction in which the axis of the mesh is being turned. So yeah, there's a lot of limitations to that. Plus, I would personally not want to paint foliage paint individual points, or just, there's a lot of room for error here. And basically this tool has been set up to kind of mitigate avoiding those kind of issues, where I can just, duplicate this guy and then just move it around and not have to worry about any kind of weird angles. So I'll break down what exactly I did here. So for this guy here, the parent mesh, as I mentioned earlier, it's set up so you can dynamically swap. So if I want to use a car instead, that's awful angle. Just that. Yeah, so in this case, like, yeah, do I have a rundown car where it's been abandoned? These placeholder meshes I'm using here, they're just for visual cues and templates. They're meant to be swapped out. But yeah, you can easily put like grass, moss, fern, or if I want to use a different rock, I can just drag and drop here. Same thing. So let me break it down for you now. This guy here. Cool. So this has been set up so it's just a template. So once again, the blueprint is the driving factor here, and it's calling to a PCG graph to take those functionalities and use these variables to control some of those functionalities. So let me close these so we're not deal with additional tabs. So here, all I did was I called a static mesh component, which houses this parent mesh here, basically saying, I want this parent mesh to be like an available slot so I can constantly just drag and drop different meshes into it. And that's all I did in this construction script here. In the viewport, you'll see that I've basically set it up. So yeah, this is just like the starting rock. It doesn't have to be this. And you can swap that out by, literally just removing it from this slot here. But for the sake of the demo, I left it. And for PCG here, it's calling this graph, which I made. And I'll open this guy up. So this is a little bit more complicated than what I was showing you earlier regarding the general landscape usage of the PCG splines. So for this one here, this blueprint, I've set up customizable variables that basically calls to certain features from the PCG graph, and it bounces back to being controlled within these variables. And I'll show you in a minute what they do, but before I do that, I'll just quickly run through how this is all set up. So this section here, as the comment states, it's just calling to the mesh itself, the parent mesh. And basically what it's saying is take whatever mesh that I put in to this parent mesh slot and generate a ton of points on there for me. And that's what it's doing. So here under attribute noise, it's just generating those points. And then density filter, this is where things get interesting. And what I'm doing here is I'm getting the actor property of the blueprint. And in this case, I'm asking for the child pruning. What I mean by that is basically all the points that are being generated, I want it to prune it at a random rate, meaning it basically controls the density in which the points are being generated on the mesh. And from there, it's calling the child fall off amount. And by fall off, it basically is saying from bottom to top, I want from 0 to 1, 1 being the top and 0 being the bottom, depending on the decimal, reduce and remove X amount of points. So if I in this case, let me just show you. So if I go 0 pruning, it's saying don't prune anything, keep everything super dense. And for child fall off, this is basically saying all the points that are down here, start removing them and calling them out as it gets closer to the top. So 0.5 is the highest. If I do 0, it's gonna generate points everywhere. So, and then if I do like 0.95, yeah, it's gonna exclusively just try to generate as much points to the top. So, and you know, in this case, it's really great for mossy rocks where if you want it to look like a chia pet, you can just go crazy and just put everything to 0. I don't recommend that because, you know, at that point, it just looks like a weird fluffy ball. But in this case, you want to use your creative instincts and just kind of do what looks good. And kind of going further down, like these two guys over here, I'm just saying, hey, these are controls for the spawning meshes to control the scale and the rotation, which depending on the use case, you don't necessarily need them. Automatically, I've already checked on the child mesh to be on. So as you see here, when I turn it off, basically what it's doing is it's scaling the child meshes. So the points will scale with the mesh itself. So if I enlarge this thing, the points will say, hey, I also want it to scale with the mesh. But if I turn on absolute scale, it'll retain the original size in which the meshes are meant to be. So if you put like grass on here, the grass won't get big with the mesh. It's a nice little feature I've automatically turned on. Turn that back on. You'll see here I have vertical mesh amount. This is a very specific use case, so it's not on by, it's always set to 0 by automatic standards, and I'll go over that down here, what exactly you need to do to get the right look that you want. But going further down the PCG graph here, you'll see I also have call distance and child mesh array. And these aren't being driven by the blueprint, specifically because this is a very PCG graph specific thing. Call distance being, you know, after a certain amount of distance, I want these points to unload. And as you see here, when I pull the camera back, you see those points being unloaded. Let me actually turn these guys up. Scale this guy up a little bit more. Yeah, you can see it there. So after a certain distance, it's basically saying, hey, turn off the points. So it's just going to be the parent mesh itself. So that's a parameter within the PCG, and I'll show you in a second how you can control that. And then over here, child mesh array. This feature is basically saying, create a bunch of templates of multiple slots if I want more than one array of meshes to be within this blueprint. So earlier when I was showing this blueprint, you noticed I had it so under mesh entries, I just input the meshes here directly at the end of the graph. But for this case, because we want everything to be dynamically drag and drop swappable, I've had to set up this additional step. So it's basically telling PCG, hey, these child arrays over here, I want to add more if I want to add more meshes, or if I don't want more than one, or if I don't want 3, I can just delete any additional one. So I can just have one type of grass on here. And that's essentially what this allows us to do. So within this guy here, I select PCG. You'll see here, I have these slots. So let me move in real quick. I can dynamically just, remove different slots. So it's, in this case, I only have cubes generating here. And then if I'm like, actually, it looked better when there was other shapes too, I can bring it back with the additional plus sign and then, just generate it. So every point that's being generated, it'll fill randomly these 3 different shapes. And, it's not just limited to shapes. In this case, what we can do is go here. Second. Ferns. Yeah. So for the sake of the demo, I'll just slot these guys in. And damn, you got your foliage on your rock. Let me go back here on absolute scale, and it should scale properly to your desired rock. And no matter where you place it in the world, if it's not directly on that exact point on that same exact rotation, the foliage will never look the same. So yeah, you can move it around and you'll get different variation. And this is kind of like letting the engine and the tool itself kind of do the heavy lifting, and all you're doing is navigating like the artistic direction of how you want these rocks to look. So if I select these two here, both of them, yeah, you can just, you know, tweak the parameters as much as you want and you get different results. And yeah, it's basically designed to be efficient and fast for you to really quickly get through this and you know, get the desired look you want. So now that I've kind of gone over the procedural mesh tool, let me show you this little scene that I built up over here. So I just took a bunch of things from the Fab library, the Paragon environment. I made some tweaks here. I added some material blends to these guys to kind of give it a little bit more of a grounded look when you put foliage on here. But yeah, basically what I did here was, if I hit Control B, you'll see it goes back to this template that I made. All I did was I took this mesh here and then what I did was like this guy, drag and drop, boom, you got the same thing right there. And then you got the points being generated on the mesh. But for this guy here, I turned off foliage. Yeah, but you can play around with it. I put some like standard grass on him, and like I said, you can make him look like a chia pet if you want, but I don't recommend it. But it's there for whatever reason that you would want to have the character look like that, or not the character, but the structure. And this is a good example to kind of discuss the vertical mesh amount. For that, basically I have it off by default. That's the wrong one. Cool. So I have it off by default mainly because it looks bad unless you use it in a very specific case. And in this case, having hanging vines off of this little statue was probably the only time it would look good. So what I'll do here is I've already set it up. So if I just put in 0.01, for example, you'll see these hanging vines generating on them. And basically what this section of the graph does is saying, hey, if the main graph tells all the points to generate on the z-axis, this other graph down here is telling it to generate on the x and y and exclude the z. So basically it's filling up the spots that the z-axis is not filling up. And in this case, it's best used for like hanging vines or, you know, roots that stick out of like a tree, or you know, displaced ground from like an earthquake for whatever reason. You know, those are just some examples I'm thinking about. So if I lift this guy up a little higher, and then you're like, oh, okay, cool, let's add more hanging vines to them. Let's go all the way to 0.5, which I've set the restriction to 0.5 because this decimal system for X and Y is super sensitive. So 0 to 0.5 is how I've set it up. Boom, look at that, it's a chia pet. Break it. Yeah, so if you turn everything off to its maximum setting, you'll see it's just this big glob of foliage. And yeah, it's set to be ridiculous like that because you never know if you ever need something to be really, really covered in, you know, flora, or, you know, like a Last of Us abandoned building or something. So let me just bring this down to a reasonable state. 5. Cool. Just bring this guy down. And yeah, so for this demo too, I've also set these rocks up to also be using the blueprint. So 0.5 and this guy too. I usually use 0.5 as like the starting point. But yeah, you know, you get a pretty good coverage of what you're looking for. If you want like a very overgrown landscape or environment or scene, this is a good tool to have for that. And like I said, you can move it around and it'll never look the same. So I can copy and paste the same thing. So if I hit Alt and drag, it's got the same amount of points, but then it will always generate slightly differently. See, look at that. So, and you know, these PCG points are going off of a wider grid in the world. So because of that, each individual point is not gonna look the same. And I think PCG really comes handy in these kind of situations where, you know, once you get to a stage where you're starting to polish your work, for example, this is a good tool to have. And I know here for this tool, I've mentioned before, it's very much just a template, meaning that, it's going to be really annoying if you have to drag and drop this every time and you're like, oh, I don't want this to be a rock. How do I get around that? The way I've been doing it when I work with this for my personal stuff is basically saving a child version. So go here, create child off the main template, and then I'll just call it, BP underscore for the sample. What I'll do here is it's basically just a copy and paste of this guy, but it's not messing with the original template. And all this does is, hey, if I want this statue guy to be the guy that always spawns instead of this rock, all I have to do here is go here, go to static mesh, go, put him here, and then for the thumbnail preview, I also put him up here, save, compile. Oh, if I go back, now you'll see, so it doesn't show you a preview of the PCG points, it only shows you the parent mesh, which I know it sounds a little annoying, but that's just the way things are done here. But if you drag it in, you'll see, yeah, the points are also now generating here. And if you're also annoyed with like, oh, I don't want these dumb placeholder assets, how do I change that? All you have to do is, you don't even have to go into the PCG graph. You have to just go into, stay in the blueprint. If you go down here, yeah, here it is. Cool. Yeah, so if you just go to the graph slot within the blueprint, you don't have to ever open up the PCG graph. You just make changes here. So you're like, I don't want these basic shapes to be here. I want to use these existing ferns that I have. Drag it, drop it, and then it'll save it as that. Save it. And then because, PCG is still in beta, it won't automatically update. All you have to do is select it. And after I saved it, all I need to do is have it selected. Click this guy, right click, replace. Boom. There you go. You got your Chia pet going on. And you got to reduce the numbers. And, with this too, you could also adjust the parameters. So under, the main blueprint here, you can change the numbers here. So by default, you have it starting at 0.9. So when you drag it in, it doesn't look like this overgrown mass. Oh. I think it's because the mesh is really small. Throw this up. There we go. Yeah, so that looks better. So that's pretty much a use case for a portfolio piece. So I think this is a good opportunity to kind of bring up, this is great from an artist perspective and it's super artist friendly, but is it, can this be used in streamlined production? And the answer is depends. This has been mainly set up for, portfolio pieces, one-offs. If you want something to look very beautiful without the worry of, hitting 60 FPS, yeah, this is a great tool. It saves you a lot of time. And, if you go off into a certain distance, you can set up the culling distances too. And here, I forgot to go over the parameters over here actually. So for case of the statue here, yeah, as you see here, I removed the placeholder shapes and replaced it with just one grass mesh. And then here are the hanging vines. And then here is the cull distance. You can even control individual cull distance too. So if I say 200, means that the grass won't spawn until I get real close. But, realistically, you don't want that. But, performance-wise, it's set up so after a certain distance, all the PCG points will unload. So if I go far enough, you see that happening. So it's great in that sense, and it's performant in that sense. But the reason why I say it might not be super ideal to use PCG this way is, just like Nanite, once you turn on the plugin, Unreal is telling the developer you're paying an upfront memory cost by turning it on. And because of that, it's best used in a more universal sense. And what I mean by that is trying to think of a good example without giving away any kind of... So imagine two different biomes. You have a jungle and a desert. You don't want... It's not performant to create two different PCG graphs for two different biomes. Realistically speaking, you have something called data assets within Unreal. And data assets basically is it's a way to house information about meshes and different kind of blueprints and have the PCG graph drive it in a way where you can tell the data asset within two different splines that are next to each other. You can say, hey, this spline is specifically calling the desert biome. And within that desert biome, you have a PCG graph set up to have a bunch of meshes that would have a biome of what a desert would have, which is sand rocks, cactuses, dried bushes, etc. And then you have your jungle biome, which, has like redwood trees and, lush forest bushes. And in that case, you want PCG to be utilizing it to its fullest. But if you're working on something that's a portfolio piece, this is a great thing to use. If it's a small indie project where you don't have to worry about super complex open world things, then sure, yeah, you can use it then. But realistically speaking, I'm just an environment artist who wanted to dabble around with something very tech art friendly. Realistically, you want a tech artist who knows what they're doing to really set up a system. And who knows, maybe this could be implemented into that said system, but from my experience, this isn't the best way to populate a biome for a big, massive space. But yeah, that's pretty much all I wanted to talk about regarding PCG and this procedural mesh blueprint that I set up.
Hey everyone, Timothy Dries here, founder of Beyond Extend. Thank you so much for watching the whole video, and thank you so much for Eugene for coming on and sharing all these cool little tricks and how to take your own little tools into Unreal Engine and take things to the next level. Speaking of which, at Beyond Extend, we also want you to take things to the next level, and we're here to help with that. As a member of our community, we have a lot of other exclusive content, such as weekly work reviews, more workshops, and our environment art handbook as well, just to name a few perks. So if you want to join us, feel free to click the link down in the description below and become a member yourselves. Stay creative, and thank you so much for all of your support.